Okay, so let's do some more trig equations here. And one of the things hopefully you'll be taught in class is to use U substitution to help you out with the factoring. But on the first one, assuming I can read it correctly, we're going to minus 4 both sides. So if we minus 4 both sides, or actually, let me stand corrected. Let's go ahead and minus 3 both sides. We'll get everything together, right? And so we'll have 0 equal to this cosine squared. I actually have my work backwards. Let's fix that. So it's just a slight change. I think the result will be the same. So sorry for the slow start here. But when I minus 3 both sides, I'm actually going to get 0 equal to 1 minus cosine squared theta. We're going to let u substitute that in. So 0 equals 1 minus u squared. Now to factor this, it's going to be 1 minus u times 1 plus u equal to 0. And this means u is still plus or minus 1. So u is going to end up being 1. Here it's going to be negative 1. So then we're just going to set cosine theta equal to 1. And we're going to set cosine theta equal negative 1. So we end up getting the same result anyways. Now where is cosine equal to 1? Hopefully you can look at your unit circle. There's only one place where cosine is 1, and that's at 0. And there's only one place where cosine is negative 1, that's at pi. All right, let's pick up the pace a little bit here. On number 2, I'm going to go ahead and add 6 to both sides. So notice I get this here, 4 sine squared theta. Right there, I'll have a minus 1 equals 0. Again, we'll let u be sine theta this time. So what we really end up with is 4u squared minus 1 equal to 0. And I actually, instead of factoring, just solved it directly. I added 1 here. And then u squared is 1/4. And then I square root both sides. So u ends up being plus or minus 1/2. Remember, whenever you do a square root, you end up with a positive but also a negative answer. So finishing this up, we know that u is either 1/2, so therefore sine theta equals 1/2, which means theta must be, look at your unit circle, the sine of 30, right? So we would say pi over 6 using radians. Now where else is sine positive 1/2? That would be in quadrant 2, which I believe is 5 pi over 6. Again, I'm trusting that you're using your unit circle. Now, where is sine theta? Because remember, u is also negative 1/2, right? So that would mean, if I'm in quadrant 3, that would be 7 pi over 6, right? I'm doing sine theta equal to negative 1/2. We'd look at our unit circle, so 7 pi over 6, and in quadrant 4, it would be 11 pi over 6. So hopefully you have those points on your unit circle, right? We want to know where, look for 1/2. Now remember, sine is y, so when you look at your coordinate, you're looking at the second value, right? You want to be 1/2. Okay? So, and sine is 1/2 at the 30-degree angles. All right. Number 3, I'm going to go ahead. Oh, that's number 2 again. So number 3, this time I notice I'm going to add sine squared to both sides to get rid of that. So now I have 2 sine squared. And then I'm going to minus 3 sine theta on both sides. Or I should say, that's a minus, so I'm going to add 3 sine theta. So anyways, when you get it all in order, you have 2 sine squared plus 3 sine plus 1. We're going to let u be sine theta. So we'll have 2u squared plus 3u plus 1 equal to 0. Doing the x method, I need a 2 with a 3, right? Don't forget to do 2 times 1 to get the 2 here. And solving that, I get u plus 1, u plus 2. Let's see here. Did I mess up? Ooh, I did make a boo-boo, didn't I? So let's fix this part here. I can't believe I did that. So notice that this isn't quite right because, remember, I need 2u squared. So I'm going to divide this by 2 and times this by 2. So let's see what our correct result is now. So here, 2u's got to be -1. That means u is -1/2. So where is sine theta equal to -1/2? Again, you'll look at your unit circle, and you'll realize, again, I'm going by memory here. I don't have my unit circle in front of me, but theta is 1/2 at 30. So theta is negative, sine is negative when the 30s are in third and fourth quadrant. So let's see, 30 would be what? Pi over 6. So our answer should be 7 pi over 6 in quadrant 3 and 11 pi over 6, 30 degrees in the quadrant 4, right? Hopefully I'm doing that right. Now here, remember I divided by 2 here. So I have u plus 1. So that means u must be -1, which means sine theta has to be -1, right? So without getting ahead of myself, it's actually 2u plus 1 times u plus 1, right? Once I do my proper conversion there and factoring. So right here, I know sine theta, which is u, has to be -1. And sine is only -1 when theta is pi or 180 degrees. No. 3 pi over 2, right, is -1. Again, look at your unit circle. That's where it should be. All right, let's look at number 4 here. Notice that there's a tangent in here. So the first thing I did, if you notice, is I added square root of 3 times cosine theta to both sides. That made this side become 0. And then at this point, notice I can factor out cosine theta. It's like a GCF. So that means I have cosine theta times tangent plus square root of 3. Well, using the 0 property, this can be 0 when cosine is 0, which is at pi over 2 and 3 pi over 2. Right here, if I solve for 0, that means tangent theta would be -3. Again, just look at your unit circle where tangent's negative square root of 3, I should say. And again, since I don't have that in front of me, hopefully I got this right in my head. I'm thinking that would be square root 3 over 2 for sine over cosine. Where is sine square root 3 over 2? That's at a 60. So that's a pi over 3. Now we want tangent to be negative. So remember, we're looking either quadrant 4 or quadrant 2. And so somewhere here, if we're looking at pi, let's see, what did I say? It was, sine was 60, so that would be pi over 3. So it should be at 2 pi over 3 here, because I'm going to do pi over 3 into quadrant through. And down here, it should be 5 pi over 3. So 2 pi over 3. Oh, that's what I got here. I already did it before. Awesome. I'm proud of myself. So, and since that came up, remember, keep track of where, like in this case, when we're solving for tangent here, remember where tangent's negative and where tangent is positive, right? And that's where you look at your unit circle to find your results. Okay, on 5. First thing I would have done here, as you notice, is I added 4 to both sides. This now I could substitute u equal cosine theta into it. and I get 2u squared minus 3u plus 1. 2 times 1 is 2 with a negative 3 in the middle. This time I didn't forget to do the divide 2 times 2, as you can see in green here. So here is the proper factored form. Solving this here, I know 2u has to be 1, so that means u has to be 1/2. Here, I just know that u has to be 1, so cosine would have to be 1 as well. So where is cosine equal to 1? There's only one spot at 0 degrees radian. Where is cosine 1/2? Again, do I have it worked out here? Yes, I do. Cosine is 1/2 at pi over 3 in quadrant 1, which is 60 degrees. And in quadrant 4, that would be 5 pi over 3. All right, one more. Here I added 3 sine squared to both sides to get my sine squares together. I then here, you notice, minus 2 sine from both sides. Rearranging it, I got sine squared minus 2 sine plus 1. I let u be sine theta. That means I get u squared minus 2u plus 1. I factor it. I get a double root where u is 1. So where is sine, which was u, equal to 1? It only happens at pi over 2 or 90 degrees. And hopefully, if you pause and watch this video enough and look at my work, you should be able to figure out each of these 6 problems very well. Hopefully the quiz is not today, it's tomorrow. All I can say is make sure you study every one of these problems. The best way to study them is you take each problem and you write it on a blank sheet of paper. Like, for example, if we were doing number 6 or studying number 6, okay, what we would do, of course, is do that, right? We would put it on a separate sheet of paper. Can we do it from scratch and redo all this awesome work, right, on your own? And besides that, I wish you luck. Just make sure you study hard. You honestly should put in at least an hour or two. You know, take breaks in between. But that's what's going to take to really master this well. You have to put in the time. An hour, 2 hours, somewhere around there should be enough for you to master both of these worksheets you gave me. So good luck. I'll see you around school.